Good morning, friends. In the last lecture, we have started the third unit of the physical chemistry, that is the nuclear chemistry. We have discussed the introductory part along with the few important terms. Now we are going to continue the next part of this unit, detection and measurement of the radioactivity. I said when this particular element, radioactive element, will disintegrate, it will emit radiation in the form of alpha or beta, that alpha, beta and gamma radiation by the nucleus. The term measurement covers the following three aspects. One will be the detection and identification of the types of nuclear radiation, that is the identification of radiation as alpha, beta and gamma rays. Determination of the energy associated with a given type of radiation, counting the number of alpha or beta particles emitted by the source in a given time interval. For this purpose, the earlier ionization chamber and the proportional counter are used to detect and differentiate between the alpha and beta particles. These counters can be used in the measurement of energy associated with the. Now the Geiger-Müller counter and the scintillation counter are used to measure the energy along with the number of this particular particles. In that we have to focus today only the Geiger-Müller counter. It is, in short, it is called as the GM counter. First of all, we will talk about the principle of this particular GM counter. One question will be fixed on the GM counter or say scintillation counter. In the Geiger-Müller counter, this particular detection and identification will be based on the principle that all type of the ionizing radiation possessing the different energies produce current pulse of the same magnitude. The potential difference is large enough to produce secondary ionization along the length of the wire that act as an anode. Very much important. As the threshold potential is reached, the current pulse start increasing. Threshold potential means minimum value of the potential is reached, then the current will start to increase. At the Geiger plateau, G should be the capital Geiger plateau, it attains a constant value. The range of applied potential over which the current remains constant is known as Geiger plateau. Here in the diagram you can see after the threshold value it start on increasing, but at the Geiger plateau it will be the constant, then again there will be the increase. Means the continuous discharge will be there, okay, after the Geiger plateau. And this particular at the plateau you can extrapolate to the voltage, that will be the working voltage. This is the principle of this particular Geiger-Müller counter. What is there in the principle? It is based on the principle of that particular ionizing radiation possessing different, you can see, energies produce the current pulse of the same magnitude. That is the main assumption or main postulates of this Geiger-Müller counter is that whatever the ionizing radiation will be there, having the different energies, they will produce the current pulse. Whatever the current signal will be there, that are of the same magnitude. Whatever the potential difference is there, it should be large enough to produce secondary ionization along the length of the wire, which will act as an anode. As I said, minimum value of the potential is reached, means that threshold potential is reached, the current pulse will increase, start to increase. But at the Geiger plateau, it attains the constant value. Geiger plateau is nothing but the range of applied potential over which the current remains constant is known as the Geiger plateau. After that, There will be the continued discharge will be there, and that we are going to monitor, that we are going to detect. We have to see the construction now. You can see here lead block is there for the radioactive sample. Why it is there? Because whatever the, when it will start to disintegrate at that time, whatever the radiation it will produce, it should not come to the environment. That's why it kept in the lead block. That can be whatever the radiations will be emitted by this particular radioactive element will be absorbed by this particular lead wall. Micro windows is there. You can see here the micro windows is there. This is the copper tube. Here in between this tungsten wire is there, and here power supply is there. Very simple construction is there for this GM counter. It consists of the copper cylinder which act as a cathode. It will act as a cathode, remember this. Cathode having 10 centimeter length and a 2 centimeter diameter with thin mica window. This is the mica window for the opening of this particular, and the rays or say or radiations from this particular radioactive elements will transfer or say pass from this mica window to the tungsten wire. A fine 0.05 millimeter thick tungsten wire act as an anode is suspended at the center of the cylinder along its axis. Very simple it is. The tungsten wire insulated from the copper cylinder. The cylinder is filled with a mixture of gas. There will be the 90% argon and 10% ethanol or bromine vapors. Argon provides ion pairs while ethanol or bromine vapors act as a quenching agent. Means whatever will be the energy, means there will be the accident we can say, that will maintain or monitor by this particular ethanol or say bromine vapors. A mica window prevents the escape of the gas from the copper cylinder to the atmosphere and allow the ionizing radiation to enter the cylinder. Working when the ionizing radiation alpha beta particles enter the tube through the mica window, they ionize the argon atoms, releasing the electrons. The electrons are accelerated towards the central tungsten wire acting as anode. The positive ions migrate towards the wall of the tube and accept negative charge from the walls of the copper cylinder and get discharged at the walls of the copper cylinder. The current is amplified and registered as a count. The same process is repeated in the absence of the radioactive sample. Some counts are observed on the GM counter because of the some radioactive impurities in the atmosphere are called as the background count. Thus counts can be reduced by using a thick lead shielding. Actual counts will be experimental count minus background counts. The number of particles, whatever the number of particles emitted by a radio element can be determined by using the actual count. The function of ethyl alcohol or bromine vapor is to prevent a secondary avalanche or say second avalanche which may be generated due to the photoelectrons emitted by the action of photons on the walls of the tube. When some positive things are there, at that time there should be the negative things, or say you can say limitations will be there. In the working, in the construction, we have seen it consists of the copper tube, copper cylinder which act as a cathode. Tungsten wire is there in the center of this particular cylinder, will act as an anode. Then mica window is there to allow to pass the alpha beta or say whatever the radiation is coming from this particular radioactive element to the chamber, ionization chamber. The cylinder is filled with the particular gas mixture, that is argon 90% and the 10% ethanol or bromine vapors. Then which provides ion pairs while ethanol or bromine vapors act as a quenching agent. The mica window prevents the escape of the gases from the copper cylinder to the atmosphere and allow the ionizing radiation to enter the cylinder. That we have already seen in the during the diagram. Very simple construction is there, and a simple explanation is there. This is about the construction that we have written in short. For the MCQ purpose, which mixture of the gas is used in the cylinder in the Geiger-Müller counter that may come. Then ethanol or say bromine vapor will act as a quenching agent that may come. Why argon is important, which will provide the ion pair, that we should have to remember what is the role of these things in particular case. Got this point? Very simple construction is there. There should be the diagram. Principle, first of all draw the diagram, also write the principle, then construction, then working, and one or two limitations you have to write, though they are asked or not. Okay. Then in the working we have seen whatever the radiation from the radioactive element enter the tube through the mica window, they ionize the argon atoms, releasing the electron. And whatever the electrons are produced, they will attract it towards the central tungsten wire acting as anode. The positive ions migrate towards the wall of the tube and accept the negative charge from the wall of the copper cylinder and get discharged at the walls of the copper cylinder. The current is amplified and registered as a count. The same process is repeated in the absence of the radioactive element. Some counts are observed on the GM counter because of the some radioactive impurities in the atmosphere. They may be the radio waves or say cosmic rays, radio waves or say cosmic rays will be there, are called as the background counts. This count can be reduced by using the thick lead shielding. Thick lead shielding you can use to reduce this particular background counts. Actual counts is equal to experimental counts minus background counts. They will give you the actual counts. Now the number of particles emitted by the radio elements can be determined by using actual count. The function of ethyl alcohol or bromine vapor is to prevent a secondary avalanche. Second avalanche means there is a sudden unwanted radiation which may be generated due to the photoelectrons emitted by the action of photons on the walls of the tube. What are the limitations of this particular Geiger-Müller counter? Whatever the voltage used for the counting alpha beta particles are quite different. It does not give information about the energy or ionizing particle, energy of the ionizing particle, because current pulses are uniform in size. Gamma rays cannot be measured effectively as they have very low ionization power. The massive positive ions takes more time, 10 raised to minus 4 to 10 raised to minus 3 seconds to reach the electrode surface because they move slowly as compared to the electrons which discharge in 10 raised to 6 seconds. This time required for complete discharge is known as the dead time. If any new particles enters the cylinder in this time interval, then the GM counter cannot count it. What are the limitations? Whatever the voltage used for the counting alpha beta particles, there is no same voltage, different voltage should be there. This is the first limitation. It does not give the information about the energy or ionizing particle because current pulses are uniform in size. Gamma rays cannot be measured effectively as they have low ionization power. The massive positive ions take more time, 10 raised to minus 4 to 10 raised to minus 6 seconds to reach the electrode surface because they move slowly as compared to the electrons which discharge in 10 raised to minus 6 seconds. This time required for complete discharge is known as dead time. Got this point? Very well. Very simple. If any new particles enter the cylinder in this time interval, then GM counter cannot be counted. It will not count for the any new particle which are going to enter in the cylinder. This is whole about the GM counter. Very simple. It is that we are counting the alpha beta particles. Please go through this part well. 5 marks question may be there based on this GM counter as a scintillation counter. Geiger Muller, the name of the scientist is there. Counter means they are counting that. That's why Geiger Muller counter, which counts the whatever the alpha beta particles that are emitted by the radioactive elements. Today we will stop here. Please go through this part. If you have any doubt, you can ask on the group. Please prepare this well. We will stop here. Thank you.